these type of problems are interesting and important. So y to the 6th, y to the 5th, and y to the 8th. They're asking us, what would you factor out? The maximum, greatest common factor, GCF, greatest common factor. So if I have these three terms, adding or subtracting them, it doesn't matter. The smallest power is the GCF. The greatest common factor is y to the smallest power, and 5 is the smallest. So imagine that we add or subtract them, these three terms, then we will factor out y to the 5th. So if I factor out y to the 5th, what is left from the first one? Just y. What is left from the second one? Well, just 1. So remember, that's why we studied exponential rules. Y to the 5th times y is y to the 6th. Y to the 5th times 1 is y to the 5th. What will be left from the third one? Y to the
third.
Exactly. Because y to the 5th times y to the 3rd, copy the base, add the exponents. That's why we studied the exponential rules. Good. So this is the greatest common factor. Now for 32x and 28x to the 3rd, how do I find the greatest common factor? The same question. We are asked to find the greatest common factor. Let's suppose we are adding or subtracting them. So 32 and 28, what do they have in common? The largest possible number that is a factor of those two. Anybody, please. What is the greatest common factor of 32 and 28?
Four.
Very good. So how do we know? Remember the factorization tree. 32 is an even number. 16 is an even number. 8 is an even number. 4 is an even number. What about 28? Even number. Even number. So you see the common factor is indeed 4. That's why we put 4. What is the common factor of x and x to the 3rd? Like before, the same concept.
X to the first power?
X to the first power. So this is the GCF, the greatest common factor of these two terms. Why is this important? Here it is why. All factoring strategy, binomial, trinomial, polynomial, they all have the same step, the greatest common factor. That's why this is super important. We need to factor out the greatest common factor first, no matter what else we need to do. Okay, in factoring, I mean. Okay, the same idea. Okay. Yeah, I would like to work on this. So here we have x to the 3rd plus 6x squared minus 2x minus 12. The factoring strategy starts with identifying the type of polynomial. We only know we only have three possible choices. It's a binomial with 2 terms, it's a trinomial with 3 terms, or it's 4 or more. This has a certain strategy, this one has a different strategy, and this one has a different strategy. So my first thought is, okay, I'm asked to factor, but first I have to identify what it is. Because based on what it is, so let me go back for a second to that handout that we started with last time. Here it is. No, not there. If you scroll down in the top module, you will see these two handouts. So this is document 2. Based on what polynomial we are looking at, see, we have totally different strategies. For a binomial, I have to go through these steps. For a trinomial, I have to go through these steps. And for polynomials, through these steps, which is basically the easiest. Just one. In addition to descending order, greatest common factor, as we said, GCF, and the negative leading coefficient. So this is crucial. So coming back to our problem, which category is it in? Where will you fit? Where will this fit? Here, here, or here? I know it's a silly question, but that's how we have to start. Is it category 1, 2, or 3? Anyone? So is this polynomial in category 1, 2, or 3? We need to know, because otherwise I don't know how to proceed.
2?
Does it have 2 terms? How many terms does it have? So can anyone tell us how many terms does this polynomial have? It's okay if you're wrong, but how many terms do you see?
4.
Exactly. 1, 2, 3, 4. So it cannot be a binomial. It cannot be a trinomial. So obviously it's a polynomial. It's in descending order and no greatest common factor in all 4. Now I know exactly what I need to do. Once I say 4 terms, let's go back to the strategy. Once I say 4 terms, here it is. There is nothing. I only have factoring by grouping. So that's exactly what I'm doing. So now I'm looking at the first term, the first 2 terms, and I have to identify what to factor out. So what will I factor out from the first 2 terms? Anybody, please? What do we factor out from the first 2 terms?
X squared?
Indeed. What is left in parentheses?
X plus 6?
Good. Do not uncover this, please. We must have an x plus 6 as a factor coming out from the last 2 terms. If we don't, we cannot continue. Good. Remember, we always need a sign and the factor.
-2?
-2. Let's check. -2 times x, correct. -2 times 6, correct. Now we look at this term and this term. And the common factor is screaming back at us. I have to pull it out. Which one?
X plus 6,
In-
x squared minus 2?
Exactly. This is it. Once I take this out, what is left is an x squared minus 2 indeed. It takes 5 seconds to verify. Before you enter the answer and may lose points, it takes 5 seconds. X times x squared. X times -2. 6 times x squared. 6 times -2. Even less than 5 seconds to verify. And now I know that this is the correct factor form. What does this mean? This polynomial with 4 terms turns into a product of two factors, this factor and this factor. Any questions on this problem before we continue? Okay, back here. Okay. What will you factor out in 36x plus 3? (36x plus 3). What will you factor out in 36x plus 3? Is there a common factor, greatest common factor? Which is?
3.
Very good. We started with two terms. Can anyone give us two terms inside here, please?
12x plus 1.
Very good. 12x plus 1. You always make sure this times this is this times this is this. Very good. Perfect. Good. Moving on. Okay, the same thing. We're going to get to other examples like this. Yeah, let's also look at something like the one you see here. Good. So this is a binomial, right? Binomial, trinomial, polynomial. It has two terms. So let's see what is common to both terms. We are looking for the greatest common factor. We always start with the numbers, then we look at the variables. So 7 and 21, what do they have in common?
Seven x cubed and y.
Very good. X cubed and y. So x cubed, y, because the smallest exponent is 3. Y power 1, because the smallest power for y is 1. We start with a binomial. We have to have a binomial inside. And of course, we have to identify what is left. 7 was taken out completely. So there is no number left in. X to the third was taken out completely. Y was taken out completely. So then what is left here? Something must be left, and you cannot say 0. Because if you say 0, this times 0 is not this. So what will I have? Say it again.
1.
Indeed.
Minus
Thank you.
3.
Yes.
X to the first, y to the first.
Yes. So from power 4, we took 3 out. So power 1 is left. From power 2, we took out 1. So obviously, there is 1 left. Again, it takes 2 seconds to verify. This times this is this. Exponential rules. This times this. Negative 21. Copy the base, add the exponents. Copy the base, add the exponents. Good. Any questions? I know it's boring, but it's very important to go through these discussions and have, okay. Okay, so here we have 4 terms. We are asked to find the greatest common factor. It's the same idea with what we just did. It's just that we have 4 terms. Same thing here with 3 terms. Okay, yes, this is an important situation. Although we know how to handle it already, let's write it. We just had an example like this a few minutes ago. So this is already grouped. You will not distribute, but you'll just say, okay, what is the common factor in these 2 terms? Basically, it's screaming back at us. What is it? That has to be pulled out.
X plus 4.
Indeed. And what is left in parentheses once we take these out?
X minus 14.
X minus 14. That's it. Good. Please stop me if you need more explanation. If you have any questions, it's not in your benefit to let me move on. If you have questions, please. Okay, let's also look at this. Negative 12x squared plus 28. Is it a binomial, trinomial, or polynomial? This is very important to identify. Binomial, trinomial, or polynomial?
Binomial?
Yes. Greatest common factor? Yes. So first the question is descending order? Yes. It's in descending order. So what will you factor out? What is the greatest common factor? Because the leading coefficient is negative, you must incorporate -1 in the greatest common factor as well.
-4.
Very good, very good, very good. Now let's see what is left in parentheses.
3x squared minus 7.
That's it. And there is nothing else we can do here. Excellent. Any questions, please? Anybody? Okay, the same idea with the trinomial. Please stop me if you want me to work on any particular problem. Yes, this is a slightly different one. 7x plus 3y plus 21. Okay, is it a binomial? Remember the flow chart, very important. Is it a binomial? Is it a trinomial? Is it a polynomial? These are the three major groups, and they come with their own strategy. So, binomial, trinomial, or polynomial? This is the first question that I ask myself. Once I put it in the correct category, I will know how to proceed. So, anybody, please? Binomial, trinomial, or polynomial?
Polynomial?
Yes, it is a polynomial. It's in descending order and no greatest common factor. My only chance is factoring by grouping. What will we factor out from the first two?
X.
Very good. What is left in parentheses?
Y plus 7.
Indeed. Do not uncover. If you uncover the other two too soon, you may get confused. You may not factor correctly. This is not cheating. This is just making sure that you are on the right track fast. Okay, now I will uncover it. Don't forget we need a sign and a factor. Not just a factor. We need a sign and a factor. And we get
+3.
very good. Now the common factor is, and we have to pull it out.
Y plus 7, x plus 3.
Very good. Once we take out the y plus 7, what is left is an x plus 3. It will take 5 seconds to verify. Y times x or x times y. Y times 3. 7 times x. 7 times 3. Again, we are saying that this polynomial with 4 terms changes or is equivalent to a product of 2 factors. Which factors? This one and this one. Why? You will see the applications. This has more applications than this. That's why we want to learn and we want to understand how to factor. Okay. Okay, the same thing, factoring by grouping, factoring by grouping, factoring by grouping. Okay, factoring by grouping. Okay, so let's say here, we are asked to look at 2 pi r squared plus 18 pi r and factor the greatest common factor. Is this a binomial, trinomial, or polynomial? Binomial, trinomial, or polynomial?
Binomial?
Very good. So we look at these two terms and let's find what is common to both. And what is common to these two?
2 pi r?
2 pi r. 2 pi r. So we took the 2 out, we took the pi out, and we took one of the r's. So there is one left, plus. From 18, we took out 2. So a 9 is left. From the pi, we took it out. And we took out the r as well. So this is it. Again, it takes 2 seconds this time to verify. Good. I think we are getting closer to 27, 28. So I'm assuming that they are probably similar with the area. Is that what we were looking at?
This works too.
Okay, very good. Excellent. So let's look at 26. Okay, so we are given a square, and the side of the square is 8x all around, of course. And there is a circle inside with a radius of 4x. And the problem is asking us, the figure shows a circle drawn inside a square. Fine. Write a polynomial that represents the shaded area in the figure. Then factor the polynomial. So they want us to represent this area as a polynomial. Any suggestion?